Hey everybody, it's Miss Berry. In this video, we're going to go over section 3.3, which is called Logical Equivalence and De Morgan's Law. We're actually skipping De Morgan's Law in this section, but that is the title of this section, but we'll skip that topic. All right, so we're going to start off by looking at this table. The top table you see is variations on conditional statements. The part of this table that's most important to write down is going to be these, well, let's see, these columns right here, first two columns. And again, these are variations on conditional statements. And then the last column over here is just how you read them. And then at the bottom down here, we have the truth values. So this is like the rules for the truth table when you're dealing with a biconditional statement. All right, so you may want to take a second and pause the video and write down these two things. So write down this top piece that I have highlighted, variations on conditional statements, and then at the bottom, the truth values for the biconditional. And they're using A and B here. Typically, we would use P and Q. All right, so hopefully you've got it written down by now. You've paused the video and you've written it down. So I just want to talk a little bit about what a variation on a conditional statement is. And then we'll get into some examples. All right, so the conditional, also called an implication, is that P implies Q, and it's read if P then Q. So there are three different variations on that conditional that we're going to look at, which is the converse, the inverse, and the contrapositive. And then we'll also look at the biconditional, which is just where the conditional goes both ways. P implies Q, and also Q implies P. So let's look first at the variations on this conditional, P implies Q. The converse of that conditional, all you do is just switch the order. All right, so the Q comes first, the P comes second. On the inverse, you just take the conditional. So the inverse of the conditional is just where you take and you negate both sides. So if not P, then not Q. The contrapositive of the conditional is sort of like the combination of these two. You switch the order around. So Q comes first, P comes second, and you negate both sides. So we have if not Q, then not P. And then the last, we have the biconditional, which, like I said, is just the same as the conditional, but it goes both ways. So P, if P, then Q, and if Q, then P. And the way that we can say this, the shorthand version of saying this is to say P if and only if Q. And we actually have a special symbol in math for if and only if. So if and only if is sometimes you'll see it abbreviated as IFF. So sometimes you'll see if and only if abbreviated as IFF. And then we have the truth values for the biconditional. So just in case you have to do a truth table and it's got a biconditional statement in it, that way you know how to fill in that column. The rest of these, you can just use your normal rules for truth tables. But the rule for the biconditional is that the biconditional will be true if the two statements are both true, or if the two statements are both false. If at least one of the statements is false, or excuse me, we'll say if exactly one of the statements is false, then it's false. So if they're both true, it's true. If they're both false, it's true. But if one of them is false and one of them is true, then it's false. All right, so let's look at an example. We'll first do an example where we have a compound statement written in words. Then we'll do a compound statement written symbolically. All right, so it says, consider the compound statement. If I go to the movies, then I will get popcorn. All right, so if I go to the movies, then I will get popcorn. And just like always, you might have to take a second, pause the video, and write this down. I'm going to go ahead and get started. So we have an if-then statement. We know that that's going to be one of our conditional statements. It's got the implies in there. So if I go to the movies, so let's call that statement P. So if P, then Q. So Q is the statement I will get popcorn. So that's our original statement, P implies Q. If I go to the movies, then I will get popcorn. And we're going to go ahead and we'll write in the symbolic version of all these things. All right, so the inverse, I have them out of order here. That was an accident. So in the table, it's written the converse, the inverse, and the contrapositive. I wrote them in a different order here, so sorry if that's confusing. The inverse was not P implies not Q, or if not P, then not Q. The converse is where it's just flipped around. The order's flipped. The contrapositive is where you do both. So you flip the order around and you negate both statements. And then the biconditional, all you do is you just make this into a double-sided arrow. All right, so now that we have all of our symbols written down, we can go back and write out in words what each of these variations on the conditional means. All right, so the inverse. If not P, then not Q. If not P, if I do not go to the movies. Then not Q. So not Q would be I will not get popcorn. And again, don't look into these statements too much. It doesn't have to make perfect sense. These are just simple statements that, allow us to practice writing the inverse, converse, and contrapositive. All right, so converse. The converse is if Q, then P. So if Q, if I will get popcorn, then P, then I will go to the movies. Technically, that word will wasn't supposed to be in there, right? But I just threw it in there to make the sentence flow better. So if I will get popcorn, then I will go to the movies. Period. All right, contrapositive is sort of like the combination of these two. So we're going to flip the order and we're going to negate both statements. So if not Q, if I will not get popcorn, then I will not go to the movies. Whoops, sorry. Pressed a button on my pen. Okay. Last one, the biconditional. Remember, this is where you do P if and only if Q. So P if and only if Q. I will go to the movies if and only if I will get popcorn. So I will go to the movies if and only if I will get popcorn. All right, so again, just using some simple statements like I go to the movies, I will get popcorn, to practice writing the inverse, converse, contrapositive, and the biconditional. Now let's do this same process, but when we start out with a symbolic statement. All right, so we're going to apply the ideas behind what we had in this table here. So we're going to be applying the idea behind the symbolic notation here. All right, so take a second, write this down. It's the same sort of format. It says consider the compound statement. P implies not Q. P implies not Q. And we're going to find the inverse, the converse, the contrapositive, and the biconditional. And again, all of these will just be written symbolically. Okay, so the inverse. Remember the inverse, that's just where you negate both sides. All right, so if we negate both sides, that would be not P implies the opposite of not Q, or if we negated not Q, that would just be Q. Sorry, my arrow looks so janky. It may not bother y'all, but it really bothers me. All right, now, so again, the inverse is where you just negate both sides. So we negated P, and then when you negate not Q, it just turns into Q. Now the converse, if you're looking at your table, the converse is where you just switch the order. All right, so this part is going to come first, and then this part is going to come second. So that would be not Q implies P. Okay. Now the contrapositive. So the contrapositive is where we really kind of combine these two. So we're going to switch the order, but this part's going to come first, and then we're going to negate both sides. All right, so switching the order, so switching these around, and then we're going to negate them. If you negate not Q, again, you get Q implies, if we negate P, we get not P. So just following that pattern. All right, and then the biconditional, that's the easy one. You don't change anything, you just make this into a double-sided arrow. All right, so you just do P, if and only if, not Q. Very easy to find the biconditional. All right, so the next thing we need to talk about is logically equivalent statements. All right, so this is the definition of a logically equivalent statement. It says a logically equivalent statement is going to be two statements or two or more statements that have exactly the same truth value in all situations. So basically, if you have two statements, you fill out a truth table and their columns match up exactly, then those are logically equivalent statements. And the symbol for logically equivalent statements is just where you have three lines. Three straight lines. So it's kind of like an equal sign with an extra line on top. That means logically equivalent. All right, so when we are determining whether two statements are logically equivalent, you have to make a truth table. So let's look at an example and we'll fill in this truth table. All right, so if you don't have your rules right beside you for truth tables, you may want to pause the video and pull up those rules out of your notes. The rules for truth tables are super important. You either need to have them memorized or you need to have them written down on your index card for the next test. All right, so it says complete the truth table for the given statements and then determine if the two statements are logically equivalent. So here's our two statements. not P, so I'm looking right here, not P implies Q, and then our second statement is P or not Q. So we're going to figure out if these two statements are logically equivalent just by filling out this truth table. If their columns are exactly the same, then we know that they are logically equivalent. Okay, so it's giving you a truth table that's already partially filled in. So they've got the column P filled in, they've got the column Q filled in, and then not P, we know that's just the opposite of all these truth values here. So you can see opposite of T is F, opposite of T is F, opposite of F is T, opposite of F is T. So that's where all those truth values come from. Let me see if I can erase all this at once. All right, and then we have the not Q column. Let me see if I can get my pen to pull back up here. Can't find my cursor. Okay. Then we have not Q column. Excuse me, we have the not Q column, which again is just the opposite truth value of whatever's in the Q column. So let's fill in this first column here. Not P implies Q. All right, so I taught about in class how it really helps if you just block out the columns that you're not going to be using. So let's take our pen and let's block out the columns that we're not going to be using. I don't know why it doesn't want my pen to pop back up. Let me try it this way. It did this to me earlier and I had to start the whole video over. I don't want to do that again. Let's see if I can figure this out. Okay. Okay. Let's see if it'll work. All right, so we're just blocking out the columns we're not using. We're only using not P and Q. So we can mark out this column. We could mark out this not Q column. All right, so now we're going to start filling in our column. Let's talk about the rule for implications. And again, this is our first column we're going to look at. This is our second, or excuse me, our second piece. All right, so the rule says, for implications, it says it's almost always going to be true. The only way it's going to be false is if you have T first and then F second. All right, so let's see if we have a T first and an F second. That's going to be false. The rest of them are going to be true. All right, so here's a T. That's the first. T first, F second. So here T, T, that one's fine. Here we have a T first and an F second, so that one's going to be false. The rest of them are going to be true. I can't see where my cursor is, so I'm kind of like flying blind here. But we are not, this is like the third time I've tried to record this video. We're not starting over again. All right, so let's now erase these squiggles because we're going to need to block out two other columns. Let's try this again. All right, so this time we're looking at the columns P and not Q. So P and not Q, so go ahead and block out the columns we're not using. All right, P or not Q. All right, let me just remind you of the rule for or. The rule for or says it's almost always true. The only way it's going to be false is if you have FF. All right, and again, this is our first column we're looking at, and this is our second. So we're looking for an F in the first column, an F in the second column. Everything else is going to be true. All right, so we have true, false. Okay, we're just looking for FF right now. True, true, FF. All right, so that one's going to be false. All right, then we're back over here, FT. All right, so that's fine. We were only concerned about the FF. All right, everything else is true. All right, now the question is, use the given truth tables, complete the truth table for the given statements, then determine if the two statements are logically equivalent. So look at your last two columns. Those were the statements we were concerned with. Are those two columns exactly the same? Do they have exactly the same truth values in all situations? They don't, right? So they are not logically equivalent. That's all that means. Okay, I'm going to just erase all of this stuff so you can see our truth table all together. And again, these are not logically equivalent because the last two columns are not exactly the same. Like here, this is a T, this is an F. Here, this is an F, this is a T. All right, we have one more. This would be number 3. No, number 4. Sorry. Excuse me. It says complete the truth table for the given statements and then determine if the two statements are logically equivalent. All right, here's our two statements. Not P and Q and P and not Q. All right, so it's already got a lot of this filled in for us. It's got the P column filled in, the Q column is filled in, not Q is filled in, and then P and Q is filled in. All right, so we're starting right here, not P and Q. So the only one we're focused on right now is just the P and Q column. So just blocking all this out. So we're doing the opposite of whatever's in the P and Q column. So the opposite of T would be F, opposite of F would be T, opposite of F is T, opposite of F is T. All right, now, last column we need to fill in is P and not Q. P and not Q. All right, so we're looking at the P column and the not Q column. So just block out the ones you're not using. All right, and let me remind you of the rule for and. The rule for and says it's almost always false. The only way it can be true is if they're both true. So your first and your second piece have to both be true. All right, so TF, that's not going to work. TT, that's going to be true. FF and FT. So everything else is false. It's almost always false. The only way it can be true is if they're both true. Okay. So now we have to ask ourselves the question, are these two statements logically equivalent? All right, so what do you guys think? Are these two statements logically equivalent? Again, we're looking at the last two columns here. Those are the two statements we're concerned with, not P and Q and P and not Q. So we're looking at these two. Are they logically equivalent? They are not. The last two rows are not the same. So these are not logically equivalent. The only way they can be logically equivalent is if they are exactly the same in all cases. All right, you guys, that is everything for this section. If you're looking down here at the bottom and you're like, oh, it says 799, it's just these last two pages are blank. So if you have any questions about this section, please let me know. Again, the most important thing for you to have written down for this section would be these variations on conditional statements. And then in the in the chance that we have a problem, a truth table problem that involves a biconditional, you may want to have these truth values for the biconditional written down. So that would help you fill out the truth table. All right, you guys, thanks for watching, and I'll see you in class soon.